we've got our three best response functions right here, and I'll explain what everything means. So people who haven't watched the last video can be all caught up. So this is player one. This is their move. So in this game, there's two firms. Firm one, or player one, has imperfect information. So they do not know whether or not the demand is high or low. So firm one believes demand is high with this probability, and believes that high with this probability, and believes that it is low with one less the probability that it's high. All divided by 2. And then firm 2 has perfect information. So firm 2, when demand is high, is playing this. So alpha H, which is the demand, and then the quantity that player 1 is supplying over 2. And when demand is low, it looks very similar, except now it's alpha L. So that is the story so far. And we want to find our pure strategy equilibrium, okay? So how do we go about this? Well, we need to solve for 3 unknowns: Q0, QH, and QL. So let's start with Q0. First thing I'm going to do is move that 2 to the other side. So we have 2Q0 equals, and then I'm going to sub in each value here, okay? Okay, so I'm going to explain my steps, and then we're going to solve for the other 2 mystery variables, okay? So I multiplied both sides by 2. I factored in or I put our Q of H and Q of L in, respectively, and then I solved for it. I realized that our Q0 over 2 appears in both situations, so I moved it to the other side, so it's 2Q0 less half a Q. So you're left with 3 over 2Q0, and then you multiply both sides by 2 over 3, and you get your final answer right here. So Q0 equals this right here, okay? So now we can solve for these 2, okay? So it's the exact same thing. Let's do QH equals alpha H less what we have here, okay? There we are. And this is all over 2. Okay? This is our first step. And then sort of imagine like a bracket here, because the less is going to be put into this, okay? And it'll make sense in just a second. So we have 3 alpha H less this probability, and this is making this less 1 less this probability L. So just as a little math recap, I'm going to go through what we're doing now. Yeah, I'm going to start from here. Well, we covered this. Okay, so now since we have our Q0, we can put it into one of these to solve for this, for one of these mystery variables, okay? So I've chosen Q of H. You can start with either which one, because we have our Q0 for either situation. And so you just plug in your Q0 where you see your Q0 here, and then you simplify it as much as you can. So I'll explain what I did. So first I put it in, and I multiplied the top part by 3, which does put everything over 6, because you can't just make it bigger on top. It needs to be equal, okay? But it looked kind of messy. It was 3 alpha H less the probability alpha H less 1 less probability alpha L. So how you clean this up, it's not too hard. Factor things out here. So you have 3 alpha H here. So you take 1 alpha H out and you've got less. So this is looking exactly like 1 less probability. And your alpha H has to be negative in here because it has to draw out 1 positive when it exits. Excuse me. So less alpha H times 1 is less alpha H, but this negative makes it positive. So you've factored that well. And then this less makes it positive, but when it leaves, finally, it'll be a positive, it'll be a negative, which it is right here. And in the case of alpha L, it works out great because alpha L is positive here and there, and you've got the same interaction and the negative. Sometimes when it gets a little messy, it's hard to see exactly how it's going to interact. So it's important when you're factoring things out, or you're factoring in, or however you're doing it, try to do it in reverse. So let's say I had made a mistake. I had either made this positive or I made this negative somewhere, or like I flipped these the wrong way. Sort of doing like the mental math backwards. Okay, well, what if I did like boom, 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 like what would happen? It needs to look exactly like this line, okay? It needs to look exactly like the line above it. This line and this line are equal to each other, except, I put the divided by 6 there, okay? So here we have our final answer, which Q of H equals 1 over 3 alpha H plus 1 less probability alpha H less LH. To get this to be positive, because it's negative up here, I did not do some voodoo magic. I just flipped these two around. Okay, so what they did, it was different, but not by very much. This is negative in their answer, and this is positive, but again, also these are flipped. So it looks like what this would have been if we hadn't flipped it. He just didn't flip it. So I'm wondering now if there's like some sort of reason why he wouldn't have flipped it. Maybe because he wants it to look the same. Probably not that big of a deal, okay? Because if you, guys, look, if you do less probability alpha H less 6, okay? All right, let's just do the math here. This goes out, chance alpha H, it's less, and this is less positive. So again, it's the exact same thing. You can write it, this is the same. This is both correct. You can do it either way you want. I just don't see why we would do it negative, because this is positive, okay? Maybe he likes alpha H going first and then less alpha L, but I guess this is both correct, so I'll write down both things. But these are both correct. Pick and choose. But you're going to notice that they're quite similar, right? It's 1 over 3 alpha L, but in this case it's 1 over 3 alpha H. If you're using my answer here, then it's plus the probability of getting alpha L less alpha H over 6. And in this case, it's the exact same thing, except it's the 1 less probability, and alpha H comes first, and then alpha L. Okay, so it's very reminiscent of our high demand. It looks similar to it, okay?